You've never seen Saturn like this before. A long-awaited image from the James Webb Space Telescope has finally been released, revealing previously unseen aspects of the planet. It appears we may have overlooked something crucial in Saturn's ring system. For years, there have been whispers suggesting that activity within these rings could uncover fundamental truths about the workings of the universe. What hidden secrets might Webb uncover in Saturn's iconic rings? The telescope, which has already delivered groundbreaking images of the early universe that challenged established astrophysical theories, is now turning its focus closer to home. We're now receiving views of the planets in our own solar system that are unlike anything captured before. Saturn, in particular, appears in the new images as though it were a completely different world. One question has long intrigued scientists: what exactly is happening within Saturn's complex ring system? Until now, researchers only had vague ideas and few dared to speculate too boldly. Thanks to Webb's advanced infrared capabilities and specialized filters, unprecedented detail has now been revealed. For the first time, scientists can peer deeply into the composition of Saturn's rings and the planet's surface below. This improved visibility is bringing entirely new features to light, features that might finally help resolve age-old cosmic mysteries. Saturn isn't the only planet undergoing a visual transformation. The telescope has also turned its gaze toward Jupiter, Uranus, and Neptune, presenting these familiar worlds in entirely new ways. Would you even recognize them? The change isn't just about visual appeal. Scientists suspect these new views contain evidence of phenomena once thought impossible. Beneath thick layers of dust and ice, there may be ancient, hidden structures, possibly even clues to something that has eluded discovery for millions of years. The idea of life in Saturn's rings, while still speculative, isn't entirely new. For some time, researchers have noticed patterns and structures within the rings that hint at activity beyond conventional understanding. Once seen as a single uniform band, we now know Saturn's rings consist of countless smaller, individual rings, each with its own unique origin and age. Some were likely formed from ice dust during the early stages of the planet's development. Others may have resulted from asteroid debris or shattered smaller moons. One of Saturn's icy moons, Enceladus, plays a major role in shaping the rings, ejecting plumes of ice and water vapor up to 10 kilometers high, continuously feeding one of the planet's outer rings. These dynamic interactions illustrate that Saturn's ring system is almost like a miniature cosmos. With the help of Webb's infrared vision, the rings appear as bright, thick horizontal bands shimmering against the dark planet. The glow comes from ice and rock particles reflecting the infrared light, offering scientists new opportunities to understand the ever-changing structure of this system. Saturn itself, shown as a deep brown sphere surrounded by a radiant ring, appears unlike any past depiction. Infrared filters serve a specific purpose here, allowing researchers to observe what's happening beneath the gas giant's thick atmospheric layers. Insights into Saturn's possible internal surface and atmospheric activity are now within reach. A previous mission, the Cassini probe, captured surprising images of Saturn's north pole, revealing a storm shaped like a perfect hexagon. Some scientists even suggested that it looked like a patch of blue sky existed in the depths, though this remains difficult to fully grasp. What we do know is limited to the outer cloud layers, much like our knowledge of Venus, where a dense atmosphere conceals the rocky interior. Although prevailing theories suggest Saturn and Jupiter consist mainly of gas, there is speculation that solid cores might still exist deep within. One particular image was captured after a 20-hour exposure using multiple infrared filters. When combined, the result shows Saturn as a glowing, dark disk in shades of warm orange and brown, starkly different from the more familiar Hubble images that depict Saturn with bright cloud bands. This contrast arises because Hubble can only capture visible light, while Webb penetrates deeper using infrared wavelengths. This difference in capability has allowed researchers to gain a new perspective on Saturn's upper atmosphere, particularly regarding the presence and behavior of methane. Methane absorbs certain wavelengths of infrared light almost entirely, making parts of the image appear dark and enabling scientists to map its distribution and density. Two distinct dark patches show particularly high methane concentrations, offering new clues about the deeper layers of Saturn's atmosphere. Methane is the third most common gas in Saturn's atmosphere, after hydrogen and helium. At the planet's edge, the atmosphere glows brightly, possibly due to methane fluorescence, or emissions of trihydrogen ions. This specific image was taken at the end of a 7-year-long summer in Saturn's northern hemisphere. Because Saturn takes nearly 29.5 Earth years to complete a single orbit around the Sun, each of its seasons lasts over 7 years, leading to extreme weather and prolonged climate shifts. These changes influence the formation and behavior of methane and other atmospheric components, which can now be observed with exceptional clarity. These detailed views help scientists track meteorological patterns and seasonal transitions on Saturn. Surface level and upper atmospheric processes offer potential insights into the planet's deeper layers, possibly leading to major discoveries. Webb has also provided new views of Saturn's moons. Surprisingly, 3 of the planet's 145 known moons appear clearly in the images: Dione, Enceladus, and Tethys. Enceladus stands out due to the towering geysers it sends into space from its hidden ocean. The recent detection of phosphorus, a key ingredient for life on this moon, makes it an especially intriguing candidate in the search for extraterrestrial life. Though Enceladus is relatively small, with a diameter of about 500 kilometers, its activity and potential for habitability make it significant. In comparison, Dione measures roughly 1,120 kilometers, and Tethys about 1,066 kilometers. Despite being smaller than major moons like Titan or Jupiter's Europa, Enceladus is uniquely active. Some of Saturn's moons are even smaller, measuring just a few hundred meters across. If life exists within Enceladus, its potential biosphere might be comparable in area to the German state of Lower Saxony. Both Dione and Tethys, with their icy surfaces and geological features, are valuable for exploration. Several upcoming missions aim to investigate these relatively uncharted celestial bodies. Webb has also turned its attention to Uranus, Neptune, and Jupiter, revealing them in completely unfamiliar forms. To the untrained eye, these new images might appear to depict glowing alien worlds rather than our solar neighbors. Their rings and atmospheric features, highlighted by different infrared frequencies, look completely different from past photos. The fact that these stunningly luminous images belong to planets we've long studied serves as a powerful reminder of how much we still have to learn. The rings of Uranus and Neptune, nearly invisible to previous telescopes, are now clearly visible. In particular, Uranus's rings shine brightly. Webb's infrared imaging allows even non-experts to notice features that have long been hidden, but these images go beyond aesthetics. The telescope's ability to read light lets scientists analyze the composition of gases and elements across planetary atmospheres with incredible precision. Uranus now reveals not just its rings, but also intricate weather patterns and atmospheric motions. Infrared light pierces through thick clouds and gas, exposing layers and features never before seen. Similarly, Neptune's turbulent atmosphere comes into sharper focus, with clearer views of its faint rings and moon Triton. Jupiter also offers new surprises. The telescope captures its atmospheric structure and immense storms in greater detail than ever. The famous Great Red Spot now appears with enhanced clarity, allowing researchers to see vertical structures and temperature gradients across and around it. These insights are crucial for understanding weather and internal processes on the largest planet in our solar system. Together, these images are reshaping how we view the gas giants and how we understand their internal dynamics, climate, and potential for harboring the building blocks of life. There is still much more to uncover.